Hi, this is day 10 of presentation Summer Algebra. Now, as we do on the days before our larger quizzes, I teach a lot less content so that you have a time to absorb what we've been doing the last couple days in preparation for the quiz. So the quiz tomorrow will be on the material taught on day 8, 9, and 10, which is today's lesson. 8 and 9 had bigger content. Today's content, day 10, is only about the sum of radicals. That's all we're talking about today. And then at the end, I'm also going to do a few extra problems, which are samples for tomorrow's quiz, 8 through 10. And I'm going to tell you exactly what's on the quiz tomorrow, exactly how many problems and how many of each type. So let's get on with our video. This might be the shortest video of the summer. And let's just go ahead and do it. Okay, so here's the deal. This topic is sum of radicals. The rule is you can only add or subtract radicals that have the same radicand. That's part of the rule. And then when adding, subtracting, just combine the coefficients to get the final coefficient. So, for example, 3 root 7 plus 5 root 7, we can add these because they have the same radicand. So check to this step. And then when adding or subtracting, I just combine the coefficients. So the coefficients are 3 and 5. So we add them and we get 8 root 7. And that's it. So it's just like, it's exactly like adding, subtracting variables. So 3a plus 5a equals 8a. The same variable, we have the same, it's kind of like having the same radical, we have the same variable, and we just add the coefficients. So it's exactly the same. Now let's move on and get to lots of examples, which is all you really wanted on this video anyway. So here are examples. So let's make sure we totally get this. So 2 root 2 plus 3 root 2, we have the same radical, same radicand. So I want you to pause and try. Pause and try. You just sit here and watch it. You're going to think you get it. You're going to kind of get it, but not nearly as much as if you do it. So same radicand. So we put our square root of 2 over here, and then we just add our exponents. That's 2 plus 3. Same thing here. We have the same base, and then we take 5 minus 3 is 2. Boom, these are easy. Here we got 3. Now what goes here? It's just like if this was an A. So just pretend this was 4a plus a minus 3a. That would be 4 5a's. That would equal 2a. Similarly, we have 4 plus 1 minus 3 is 2 root 3. 6 root 2 minus 6 root 2 is just 0 root 2 or 0, right? You take something and subtract it out, you better get 0. 2 root 5 minus 5 root 2, that's something root 2. No, no. We have different bases, so you can't combine them. Different, they're not bases, different radicands. So our answer is still 2 root 5 minus 5 root 2. Can't simplify it. And here we can say, well, this has a different radicand. So this one stays the same, but we can combine this one, and that's going to be a root 3. And we got 3 and negative 2. So that's 1 root 3 plus 6 root 2, or simply root 3 plus 6 root 2. Got it? All right, let's move on. Let's get a little trickier. Well, look, these are different, so we can't combine them. Well, yes, we can, because this can be simplified. This has a hidden factor of 4. So this is square root of 4 times the square root of 2, which is 2 root 2. So square root of 8 is 2 root 2 plus root 2, but equals that. So that's 3 root 2. Right? This is 2 root 2 plus root 2. We can do the same thing here. We get 2 root 6 plus, and this here is the square root of 4 times the square root of 6, which is 2 root 6. So 2 root 6 plus 2 root 6 is 4 root 6. Right? So we always have to simplify first. This one, we can just see all this simplification. This one here simplifies to square root of 16 root 2, which is 4 root 2. So we can rewrite this whole thing as 4 root 2 minus 4 root 2, which is equal to 0. Here, this one can be simplified into 3 root 3. I'm just do it all at once. So that's 6 root 3 minus 3 root 3. And this one here is 2 root 4 root 3. Root 12 is root 4 root 3. So 2 times 2 is 4 root 3. So here we have 6 and 4 is 10 minus 3 is 7 root 3. So I'm doing these fast like you guys asked. I'm just going through lots of examples. Okay, this one gets a little bit trickier. We can simplify this guy. So let's take this one and simplify it, and then we'll do our addition. So this is the square root of 1 over the square root of 3, which is 1 over the square root of 3. We got to rationalize our denominator, and we get root 3 over 3. Okay, so now we have the square root of 3 plus 1/3 the square root of 3. The square root of 3 over 3 is 1/3 the square root of 3. Well, what are our coefficients? Well, it's 1 and 1/3 root 3, but that's better written like this: 4/3 root 3, or 4 root 3 over 3. Either one. Okay, we can still do other stuff here. Let's see. This here is a distribution problem. So this is root 6 plus square root of 2 times the square root of 2 is just 2 plus 5 root 6. 5 root 6 and root 6 is 6 root 6 plus 2. Can't combine that with 2. Gonna have something similar over here. Let's see, we got square root of 50 plus 5 minus 3 root 2. Well, square root of 50 is square root of 25 square root of 2, which is 5 root 2. And we'll move the rest of this down, plus 5 minus 3 root 2. Well, 5 root 2 and minus 3 root 2 is 2 root 2, so we get 5 minus 2 root 2. Square root of 3 plus square root of 6 is square root of 8. No, cannot combine. Can't combine. And neither one of these can be simplified, so we're just left with that. And 4 times the square root of 2 times square root of 2. Oh, this is a trick question. This is multiplication. multiplication. So what do? We multiply the outsides and we get 4, and then we multiply the insides and we get square root of 4, and that's just 4 times 2, which is equal to 8. All right, now that was fast. Now let's just do, here's our test. Tomorrow's quiz is day 8 through 10. It's day 8 through 10. So we're going to have 12 exponent or power problems. We're going to have 8 radical problems, 3 solve exponent problems without using the rule. So how do you do this without using the quotient rule? How do you do it? You know, you do this with expansion, otherwise known as the definition of powers. Then we're going to have 2 scientific notation problems like this, where we just multiply or divide, and then we're going to have 1 scientific notation word problem. And I'm not going to tell you, I mean, we've done some already, and I'm not going to give you any further hints. So I'm just going to go through and work these real fast. Let's do them in black. Wow, never do things in black. So our exponent power, this is x to the 5th. This here is this times that. So we get x squared y cubed. Here, these positive powers don't need to be dealt with, but we have to get rid of these negative ones. So the way you get rid of negative ones is you move them to the other side. So we're going to move our b up top and move our x down bottom. So on top we have b to the 4th y squared, and on the bottom we have a cubed and x squared. I keep it alphabetical, right? A then x, b then y. I wrote them in that order. All right, simplifying radicals. Let's see. Well, this might get a little ugly, but let's do it. Square root of 20 over square root of 7. Well, square root of 20 is square root of 4 times square root of 5, which is equal to, and I'll do this all at once, 2 root 5. I did that in one step instead of 2, over root 7. Now we have to rationalize the denominator, root 7 times over root 7. So we get 2 root 35, which can't be simplified, over 7. This, we can say, well, square root of 18 is, well, we get 2 root 2. We're going to copy that over. But square root of 18 can be simplified to 3 root 2. Again, I'm doing it in 2 steps rather than 1 step rather than 2. And that's 5 root 2. Okay, scientific notation. Solve this using expansion or definition of powers. That's x times x times x times x times x. We can't just take 5 minus 2 because we're not allowed to use the rule. We can only use definition of powers. So now we cancel, 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 and we're left with 3 x's on top, so that's x cubed. Let me do it like this. That equals x cubed on top. All right. Scientific notation. Here, 3 times 4.1. We multiply these, which is 12.3 times 10, and we add our exponents, which is 10 to the 0. Well, this is not in exponential notation, so I need, or sorry, not in scientific notation, because this number is too big. So this 12.3 is 1.23 times 10 to the 1st. And then we got to bring our 10 to the 0 down. And now simplifying this, we get 1.23 times 10 to the 1st. And those are our examples. We are done with this lesson. I think it is the shortest one that we've had this year. So good luck on tomorrow's quiz. I will see you tomorrow. Happy studying. Let me know if you like the videos. Feel free to comment, ask questions, et cetera, et cetera, et cetera, et cetera, et cetera. And bring a good joke to class. I mean, tell a good joke. We can, you know, liven it up, and I'll give you the floor. Heard some good ones so far. Some bad ones so far. Love you guys. Dog's not here. Can't share the dog with you.